All right, so we're gonna be working on simplifying algebraic expression today by combining like terms. So before we start, we usually have something like we ponder upon. If you were a superhero, what would your name be and a special power? So again, if you were a superhero, what would your name and special power be? Alana, go ahead.
I'd take all of Superman's powers and I guess I'd be Supergirl.
That is very true. Tiffany, what will be your superhero?
My name would be TJ Cherry Tomato just because that's my nickname. Most of my friends would go by for me. My initials and a fruit or vegetable. And then I just talk to animals.
Oh,
And I like animals. Talk to animals.
that is cool. All right. Anyone else? What is your name gonna be? Aiden. David. What is that? Walls change. I could not read them. It's like there's no space in between. Aiden, what will you be? Come on, unmute people. You could talk. That will be your superpower.
I would have powers of high intellect.
Oh, so you're one of those brainy one, huh? In the what is that? Those superheroes masterminds?
Tech person, like the tech person in the background giving all the info to the superheroes on the battlefield.
Correct.
Tell some robbers to stop and have some, I don't know, back the formula and telling them to stop. Yeah, exactly. That's not gonna work.
Aiden say Jimmy is the one. Anybody else would like to share what superhero they would like to be? I want to be what? The mathematics. What is that? So you could solve calculus. You don't need to be a superhero to solve calculus. Anyone else?
Mathematician.
So
yes. We're stuck in this problem which we need maths to solve to get out this.
And he said he wanted to be the wizard. And who else? You guys, let's see what you guys hear is.
I'd also have the power of time travel, so I could see one when this pandemic will end. Two, I could settle the argument of how we like how the world began. I could go back to the beginning of the earth.
Oh, correct.
And then I would like travel anywhere, but then not really travel. So so I don't mess up the space-time continuum and like end up not being born or something like that.
I could see you watch so much superhero thing you have, Anna. Me too. I'd like to have that superpower that I could travel. So I'll avoid COVID. Oh, this is a nice picture. Avoid COVID for using travel time, right? So, like a portal that create a portal. Crazy, but yeah, that's what we want to be. Getting vaccines. So our goal for today is to simplify algebraic expression by combining like terms. We already know this, but we'll just be more specific on what kind of terms. Yesterday I realized some of you still struggle what combining like terms means, but we discussed this already before, but we're going over it. So we'll go to Savas today. We'll see. Let's do this one first. Solve and discuss. And I did not put a pen. Can you write over this? Yes? Okay. I'll give you a minute to write. So write an expression equivalent to x plus 5 plus 2x plus 2 by combining as many terms as you can. Solve this problem in any way you like. I'll give you a minute. How do you combine these terms? What did you do before I go look at your work? Anybody would like to share how did you find this answer? Selena, what did you do?
I added the like terms 5 and 2 to make it 7, and because 2 we don't know what's x and 2x, so I just made it 7 plus 2x plus x.
All right. Omar, would you like to add to that?
I did the exact same thing as Selena. I did 5 plus 2 since 2x is not the same thing as 5, so I did 5 plus 2 is 7. 7 plus 2x and then plus x.
All right, we'll take that. Alana?
I did 2 plus 2x, which equals 2x, and then I did 5 plus 2, which equals 7. So I did 2x plus 7.
So anybody else would like to share on what they answered? You guys are almost correct, right? Like if I gonna look at the answers that you guys have here, let me look at what you guys have. So wait, I thought you were able to answer them. So you guys have 7 and 2x plus x and 2x plus 7. You got x5. Where you get x5? You could only combine. Actually, you could only combine like terms. I want to look at somebody. Oh, so that's 7 plus 2x plus 2. All right. So I haven't seen anyone exactly the answer. I'll stop on this one. All right. Maybe I'll look more. So that's 7 plus 3x. Who answered this one? 2x and 2. So far, based on what I've seen, I only see one exactly correct answer and couple of them that is almost correct, right? Because it doesn't really say simplify your answer to a binomial. So when we say we combine like terms, it should be the same variable, the same term, correct? If I'm gonna represent x as bananas, okay? Right, Tiffany, I think you get it right. So let's say I'm gonna represent x as number of bananas. So here I have 1 banana, I have $5, I have 2 bananas, and I have $2. And I put them together as group. What do you think it's gonna be? How many bananas will there be, Omar?
I didn't hear you the first time. What's the...
So if I'm gonna represent x as banana or apple, or let's say banana because I started with that. If first x is, I have 1 banana here, I have $5, I have 2 bananas, and I have $2. If I'm gonna combine them as the same group, how many bananas will I have?
You're gonna have 3 bananas
You're
because
gonna have
the x is 1.
Yes, that's gonna be 3 bananas. So I could do that as 3x. And then what else I could group together, Alana?
You could group together the $5 and the $2.
Correct. So it's easier when you name them into an item. So it's easier for you to group together. So that's gonna be 7. So now you could have 3x, because I know you forgot about x. Some of you said 2x plus x, they're not the same. It's not the same maybe because you think of the coefficient, but the variables are the same, their exponents are the same. Just think about like they are the same group. The only thing is that's only 1 and that's 2. So that's have 3 of those x. And then 5 and 2 together. So that there will be your final answer. You're gonna put this together, okay? 3x and 7 is equivalent to 3x plus 7. You cannot put them as 10x. They are not the same. We could only combine the same term. The same term. The same term means the exponents are the same, the variables are the same, and the constants are the same. Before I proceed, Omar has a question. What is it, Omar?
I thought that we're not like x. I thought we were not supposed to assume that's 1. So in this case, I feel like we're assuming.
No, we're not. No, we're not. It's like if you have something like k or r, so there is a coefficient. If we're not assuming, there is really a coefficient of 1 and the exponent of 1. We're not assuming a value of r or the value of x. This is really 1x, not 1. It's x. There's only 1x, not representing. If I'm gonna change this to 1, then this is gonna be 8. But I did not do that. We group this is one variable and there are two variables. So there are three variables of x, okay? Assuming is different from combining, right? Or representing the variable. If I'm gonna say let x equals 1, then this gonna be 10, because this is 1, that's 5, that's 2 times 1, that's 2, then the value is 10, okay? But we're not doing that unless maybe, what if x is 4? So that's 3 times 4 plus 7. All right, Omar? No assuming, okay? Unless it tells you let x is 5, let x is 1. I think you're thinking of, if you have a variable like that, it means it has 1. So let's say you have letter V. That means 1V. That means 1, but there's still V here. All right, that means 1V. It doesn't mean anything else, but just 1V. Or U, it means 1U. Okay? All right, let's see what Sabas is telling us to do today. So let's proceed to our next. Is it playing? Yep, it's playing. It's just loading forever. There you go.
How can you combine like terms to simplify algebraic expressions? Let's look at an example. Terms that have the same variable part, such as y and 2y, are like terms. To simplify algebraic expressions, you use properties of operations to write equivalent expressions that have no like terms and no parentheses. Write simplified equivalent expressions for x plus x and 2y minus y.
So if we're gonna base it to what we've discussed a while ago, what will be the answer if I combine this one, x plus x plus x? Alana?
It's gonna be 3x.
It's gonna be 3x, correct. Tiffany, what will it be when there is 2y minus y?
It's just gonna be y.
Okay, so it's just like
Y.
yes, 2 yo-yo minus a yo-yo is 1 yo-yo, just y. All right, that's correct. All right, it's not 2 because others said 2y minus y is 2. No, it's 2y. Like there are 2 yo-yo minus 1 yo-yo, so there's only 1 left. Play.
Combine the like terms in x plus x plus x. All three terms are like terms because they all have the exact same variable, x. You can use the identity property of multiplication to write x as 1x. Use the distributive property to show the expression 1x plus 1x plus 1x as the quantity 1 plus 1 plus 1 times x. The expression the quantity of 1 plus 1 plus 1 times x is equivalent to 3x. A shortcut you can use to find this answer is to add the coefficients and write the common variable. So 3x is equivalent to x plus x plus x. Combine the like terms in 2y minus y. Why are 2y and y like terms? They both have the exact same variable, y. Use the identity property of multiplication to show the expression 2y minus y as 2y minus 1y. Then use the distributive property across subtraction to show the expression 2y minus 1y as the quantity of 2 minus 1 times y. The expression 2 minus 1 times y is equivalent to 1y or y.
You guys got questions?
A shortcut you can use.
Like, you guys got a question for this one? We're good, right? So we're just gonna subtract the coefficient of them as long as they have the same term. The same term means the same variable and everything like that.
Use to find this answer is to subtract the coefficients and write the common variable. So y is equivalent to 2y minus y. Now you know how to combine like terms to simplify algebraic expressions.
Two, it's like how we're gonna use that in a problem. Okay.
A new hiking trail includes 3 sections of an old trail. The park ranger marked the sections of the trail in relation to the length of the flat stretch of the trail, which is n meters. What is the simplified expression that describes the length of the new trail?
So there will be a trail, like the new hiking trail includes 3 sections, like a triangular trail because it's 3 sections. So a trail we're gonna go around it. So the park ranger marked the sections of the trail in relation to the length of the flat stretch of the trail, right? Which n meters. So let's look at the diagram of this trail. So here they are. It's like from here to here is 2/3 n. From here to here is 2n plus 4, and from here to here is n. Then it's gonna ask you what is the expression that describes the length of the trail. So from here to here, from there, and from there. So using our idea on how to add fractions, we could use n plus 2/3 n plus 2n plus 4. So that's the first one, that's the n, and then this 2/3 n, and then 2n plus 4 is here. We combine like terms, so we combine all the n's together. So n plus 2/3 n plus that, so that's 1n plus 2/3 n plus 2n. That gives us 3 and 2/3 n. 1 and 2 and 3 and 2/3 n. That gives us plus 4. So the final answer will be 3 and 2/3 n plus 4 if we're gonna add this together. We're just gonna use our knowledge on how to add rational numbers. Question to that? No? Alright, so you're gonna work on page 3. So let's look at example number 3 that they give us. So here we go.
This summer, Vanna wants to charge 2 5/10 times as much for mowing and raking, but her expenses, $10 per weekend, will also increase 2 5/10 times. The expression below can be used to find how much Vanna will make this summer mowing and raking X lawns in a weekend. 2 5/10 times the quantity 20 and 50 hundredths times X plus 5 and 50 hundredths times X minus 10. How can you use the properties of operations to write a simplified equivalent expression without parentheses?
What is the first step we should be doing to solve this problem? Alana.
We have to solve parentheses and sit inside of the parentheses as addition and subtraction. You just solve from left to right.
So, if based on what... Hi.
I'm here.
Yes. Okay, so everyone is here. So, based on what you said, right? So, we could combine what is inside the parentheses. So, what are we combining first inside the parentheses?
2.
Go ahead, one at a time.
20.50x plus 55.50x, and that's gonna give us 26, I think.
So that's gonna become, so I'm gonna put here 2.5 times what? That gonna be 20. That's gonna be 20 what? 26, right?
26.
That's gonna be 26x minus 10. What will be the next step? What will be the next step we're gonna do here?
We will do 26x minus 10.
We cannot do that because they are not the same term. So anybody has a different idea? Briar?
2.5 times 10 and times 26.
So 2.5 times what again? Say again. Sorry.
26x.
Times 2.5. And what?
And then times 10.
And then 2.5 times 10. Make sure you distribute 2.5. So that's gonna be 2.5 times 26x. How much will that be? Can someone
But you
get a
can't
calculator?
multiply 26x by 2.5 because they're not like terms.
Oh, you could multiply. You cannot combine.
Okay.
Alright, so good that you said that. But you can multiply. The only thing you cannot do is combine them. My pen is really like acting crazy. So good that Alana mentioned that.
Times 26 is 65.
Okay, 65x.
Yes,
And then
65x.
this is gonna be 20. Is that 25?
Yeah, because for 10 it moves the decimal point.
Yes. So I'm gonna make that because I got it wrong. So that's gonna be minus. Oops. So that's gonna be minus. So we could multiply, but we could not combine. So we could multiply 2.5 times to any variable inside the parentheses. We could still distribute them. And then 25 times 26x, they're gonna be 65. Then 2.5 times 10, what did I say? 25. I said 2.5. 2.5 times 10 gives you 25. And since we could not combine anymore, so that's gonna be your final answer. Okay? So that's gonna be your answer. Let's try to practice on the given activity that it's on the next pages of this one. So if you go back to the presentation, I'll asking you to go check your Google Classroom. In your Google Classroom, you could go back to the Sabbath's work that I give you. Lorraine, you don't need the link anymore. We're just gonna go to our Google Classroom, okay? Alright, just work on your Sabbath day, guys. And you could exit your period deck. I will exit mine too.